channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your chemistry for class 11. That has been your part 2, which is we have done your part 1 in the last classes, and even though we had done your 7 units, 7 chapters on that as well. Today we're going to start with your, that has been the second class of this part 2 that we have to discuss here, which has been we are dealing with unit 1 here for the same. That is, you can see that unit 8 we are dealing with, that has been the redox reaction, and here many of the topics we had done. So before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So let's start with the starting with in the last class I had told you about redox reactions in the terms of electron transfer reaction. That is the last topic we had done. In terms of, we had to explain you about reduction reaction, reducing agent, oxidation, reduction, oxidizing agent, reducing agent as well. We'll start discussing about the question from here so that you will get to know about it. So please go ahead with like, share. It has been justify that the reaction, so the equation we have 2Na plus H2 will give you 2NaH is a redox change that has been. So here that yes, the solutions in the above reaction that the composed formed in an ionic compound, which may also be represented as Na plus H minus. This suggests that 1/2 reaction in this process, so it will be give you like in the form of 2Na, that will give you 2Na plus 2 electron that we have. And on the same phase we discuss about it, which is we have to even discuss here in the detail here, which has been and the other half reaction we give here is your in the form of H2 gas in the form of gas, 2 electron, it will give you 2 H minus gas here. So this that splitting of the reaction under examination into 2/2 reaction automatically reveals that here sodium is oxidized and hydrogen is reduced. Therefore, the complete reaction is a redox reaction here. Now we talk about the another topic here, and that has been the competitive electron transfer, which has been the important, of course, and that's what we have to discuss here. And so when you run through with the these type of topics, you have to consider about what you are dealing for and what you have to deal with. So let's find dealing with competitive electron transfer reaction. Competitive electron transfer reaction. So that we go, and that is we have to even though talk about it here for competitive electron transfer reactions in this when you find it out. So here that you have to place a strip of metallic zinc in an aqueous solutions of copper nitrate, and for about 1 hour you may notice that the strips becomes coated with the reddish metallic copper, and the blue color of the solution that disappears. The formations of Zn2 plus ions among the product that can easily be judged, and when the blue color of the solution due to Cu2 plus that has disappeared, and if hydrogen sulfide gas is passed through the colorless solution that containing Zn2 plus ions, appearance of white zinc sulfide and ZNS that can be seen on making the solution alkaline with ammonia. The reaction between metallic zinc and aqueous solution of a copper nitrate that we have as follows. ZNS plus Cu2 plus aqueous Zn2 plus aqueous plus Cu S that we have. In this, in reaction, zinc has lost electron to form Zn2 plus, and therefore zinc is oxidized. Evidently, now if zinc is oxidized, realizing electron releasing electron, that something must be reduced. Accepting the electron lost by zinc. So copper ion is reduced by gaining electron from the zinc. The reaction can be written as Zn plus Cu2 plus aqueous will give you Zn2 plus aqueous plus Cus here, and for the same it will be gain of 2 electron, and here it will be release of 2 electron that we have. Okay, so for the same, here redox reaction between the zinc and aqueous solutions of copper nitrate that are occurring in a beaker that will draw here, and that I will just explain you for the same. Redox reaction between zinc and aqueous on. For the same we talk here, and that is the redox reaction between a zinc and an aqueous solution of copper nitrate that occurring in a beaker. So for the same it will be here that this is being the zinc rod that placed in copper nitrate solution. Zinc rod placed in copper nitrate solution. This is your initial stage, and here it has been intensity of blue color. This has been the texture is blue color is reduced. Coming towards this has been the intermediate stage. And this, here the copper has been occurring pure, so that has been the finally Cu2 plus is deposited as Cu, and this has been the final stage. For that it has been Cu that has been here deposited on zinc. Okay, now we talk about redox reaction between the copper and aqueous solution of silver nitrate occurring in a beaker. This has been the light one. This is an initial stage. This is copper rod dipped in silver nitrate solution. Here it will be your blue color starts developing on the next stage. That is it is here. So here the copper has been removed, and this is all we have. Next, this will be an intermediate stage. Now the further, this is intensity of blue color increases, and then so this is what we have. Okay, this is your final stage. Here it has been is silver deposits on the rod. So this has been the redox reaction between copper and aqueous solution of silver nitrate occurring in a beaker. So we are at that equilibrium where the chemical test here, which has been the chemical test that reveals that both Ni aqueous and Cu2 plus aqueous that are present at a moderate concentration on the same phase here, which has been in this case then neither the reactant CO, or which is in the form of solid, and Ni2 plus in aqueous solution, and or the product CO2 plus in aqueous and Ni solid that are greatly favored as well. This competitions for release of electrons incidentally remind us of the competitions for release of protons among acids. The similarity suggests that we might develop a table in which metals and their ions are listed on their basis of their tendency to release electron, just as we do in the case of the acid, to indicate the strength of the acid. As a matter of fact, we have already made certain comparisons. By comparison, we have come to know that zinc realizes the electron to copper, and copper releases the electron to silver, and therefore the electron releasing tendency of the metal is an order, which is in the form of an order of Z is Z, and zinc is greater than Cu, and that is greater than Ag. We would love to make our list more vast and design a metal activity series of electrochemical series as well, with the competition for the electron that between the various metals that help us to design a class of cell which is named as a galvanic cell, in which the chemical reaction became the source of the electrical energy. We will study more about these cells in the next classes, that has been the class 12. We will discuss for the same. Now on the same behalf of it, we talk about it. We'll discuss about the third one, which is being the oxidation number. So we go for the same. So here the third category is oxidation number. In terms of oxidation number here, which we talk about it, a less obvious examples of electron transfer is realized when hydrogen combines with oxygen and to form a water. By the reaction, it will be your 2H2 gas plus O2 in the form of gas will give you 2H2O, which is in liquid. Here, though not simple in its approach, yet we can visualize the H atom, that is mean hydrogen atom, as going from a neutral zero state in H2 to a positive state in H2O. The oxygen atom that goes from zero state in O2 to a negative state in H2O. It is assumed that there is an electron transfer from hydrogen to oxygen, and consequently H2 is oxidized and O2 is reduced here on the same phase. However, as we shall see the later, the charge transfer is only partial and is perhaps better described as an electron shift rather than a complete loss of electron by hydrogen and gain of oxygen. What has been said here with respect to this, it has been that may be true for a good number of other reaction that involving a covalent compounds, and two such examples of these classes of the reactions are we have so for the same it will be your net that do not be simple as an approach that we can visualize the hydrogen atom as going from neutral zero state to H2 and to a positive state in H2O. The oxygen atom goes from zero state to in O2 and to the negative state in H2O, and it assumes that there is an electron transfer from hydrogen to oxygen, and consequently H2 is oxidized and O2 is reduced. However, as we shall see later, the charge that transfer is only partial and it perhaps better described as an electron shift rather than a complete loss of electron by hydrogen and gain by oxygen. What has been said here with respect to that equations that we had done here in the same way, that may be true for a good number of other reaction that involving the covalent compound. Two such examples of these class of the reaction category we have. So that is being is being follow H2 gas plus this is sorry H2 is this means solid, Cl2 gas will give you 2HCl form of gas, and CH4 gas plus 4Cl2 gas that will give you CCl4 gas, CCl4 liquid plus 4HCl gas that we have here. In the same phase with respect towards it, in order to keep a track of electron shift in chemical reaction that involving the formations of covalent compound, where a more practical method of using oxidation number that has been developed. In this method, it is also assumed that there is a complete transfer of electron from a less electronegative atom to a more electronegative atom as well. For example, we rewrite these equations to show charge on each of the atom that forming a part of this reaction. So it will be as follows: 2H2 plus O2 gas to H2O, 0, this has been 0, there plus 1 and minus 2. Next is for H2 solid plus Cl2 gas 2HCl. For this it will be your here has been 0 0 and this is plus 1 plus minus 1. Another equation we have here CH4, this is minus 1 minus 4 plus 1 0, then it is being your plus 4 minus 1 plus 1 minus 1. It may be emphasized that the assumptions of electron transfer is made for bookkeeping purpose only, and it will become obvious at the later stage in this unit that it leads to a simple descriptions of redox reaction. Now for the further way we talk here is being the oxidation number that denotes the oxidation states of an element in a compound that is being ascertained according to a set of rules that is being formulated on the basis that we have here. So on the same basis we talk about it, the same basis electron is in a covalent bond that belongs entirely to more electronegative element as well. So here it is not always possible to remember or make out as easy in the compound or ion which element is more electronegative and then the other here. For the same it will be therefore a set of rules that has been formulated to determine the oxidation number of an element in a compound or ion. If two or more that has been two or more than two atoms of an element that are present in the molecules ions such as Na2S2O3 or Cr2O7 minus, there the oxidation number of the electron atom of that element will then be the average of the oxidation number of all the atoms of that element. And we may at this stage that use the calculations of oxidation number, and these rules were that is being the first rule we have here for the same is being in the element that in the free of uncombined state, each atom that bears an oxidation number of 0, evidently each atom in H2 with O2 Cl2 O3 P4 that is your S8 NaMgAl has an oxidation number which has been 0 here. The next we talk about here for the same, that for ion compound composed of only one atom, that the oxidation number is equals to the charge on in ion, that is thus Na plus ion has an oxidation number of plus 1, Mg2 plus ion plus 2, Fe3 plus ion plus 3, and Cl minus ion minus 1, O2 minus ion minus 2, and so on. In their compound, all alkali metals have oxidation number of plus 1, and all alkaline earth metals have an oxidation number of plus 2. Aluminium is regarded to have as an oxidation number of plus 3 in all its compound as well. The third rule we have that the oxidation number of an oxygen in most compound is minus 2. However, we can come across two kinds of exceptions here. One arises in the case of peroxide and superoxide, the compounds of oxygen in which the oxygen atom is directly linked to each other. While in peroxide, example H2O2, Na2O2, each oxygen atom is assigned an oxidation number of minus 1. In superoxide, example KO2, RbO3, RbO2, each oxygen atom is assigned an oxidation number of minus 1 by 2. The second exception appears rarely, that is when oxygen is bounded to fluorine in such compound, example like oxygen difluoride which is OF2 and dioxygen difluoride which is O2F2. The oxygen is assigned an oxidation number which is of plus 1 and plus 1 plus 2 respectively. For the number that has been assigned, the oxygen will depend upon the bonding state of oxygen as well, but this number would now be a positive figure only. The next we talk about the next fourth rule, we have the oxidation number of the hydrogen is plus 1 except when it is bounded to a metal in binary compound, that is the compounds that containing two elements. For example, in LiH, NaH and CH2, its oxidation number is minus 1. In all its compound, fluorine has an oxidation number of minus 1. Other halogens, which is being chlorine, bromine and iodine, also have an oxidation number that is that have an oxidation number of minus 1. When they occur as halide ion in their compounds, the chlorine, bromine, and iodine, when combined with oxygen, for example in oxo acids and oxo anions that have positive oxidation number as well. So we go for the next here, which has been the another rule, and that has been the sixth rule and the last rule, of course. The algebraic sum of the oxidation number of all the atoms in a compound that must be 0 in polyatomic ions, and that the algebraic that's the sum of all the oxidation numbers of atoms of the ion that must be equals to the charge of the ion, and thus the sum of the oxidation number of 3 oxygen atoms and 1 carbon atom in the carbonate ion, which is CO3 O2 minus, must equal -2 here as well. In the same case here, by the application of the above rules, we can find it out the oxidation number of the desired element in a molecule or in an ion, and it is clear that the metallic here, the elements have positive oxidation number, and non-metallic element that have positive or negative oxidation number. The atoms of transition element usually display the several positive oxidation state. The highest oxidation number of the representative element is the group number of the first two groups and the group number that -10 following the long term of the periodic table, and for the other group, thus it implies that the highest value of the oxidation number exhibited by an atom of an element generally increase across the period in the periodic table. In the third period, the highest value of the oxidation number that changes from 1 to 7 as indicated below in the compound of the element as well. On the same page, the term that is being often by interchangeable with the oxidation number is the oxidation state. Thus in CO2, the oxidation state of the carbon is +4. On the same page, that has been also the oxidation number, and similarly the oxidation state as well as the oxidation number of oxygen is that is being your -2. This implies that the oxidation number denotes the oxidation state of an element in a compound. In the same phase, here we'll discuss about the groups and the element, of course, and which is will be in the next coming class. We'll discuss about it. Here we're going to end up with, but before ending it up, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. So, but other than this, we had done your sociology and software engineering, even though we had done the chemistry part 1 for class 11, chemistry part 1 for class 12 as well. Even though we had in class 12 part 1 for chemistry, we had done your unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9 with the convergence logarithms and antilogs. We had even though started with physics part 1 for class 11, that we had done your physical world, and we are dealing with units and measurement of unit 2. Other than that, we are dealing with AR diagrams, we are dealing with English vocabulary, we are dealing with PHP interview questions, general knowledge and important facts about the countries, as well as we had done your reasoning. In that, we had done your general mental ability and the logic reasoning for verbal reasoning, and the non-verbal reasoning we had done your series analogy classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice, dot situation, constructions of squares, triangle, figure formation, analysis and practice question set as well. In terms of quantitative aptitude, we had started with arithmetical ability. In that, we had done your which has been operations on numbers, the CFS and SCF on numbers, decimal fractions, simplification, square roots and cube roots, problems on numbers, prompts on ages, search analysis, percentage, profit and loss, ratio and proportion, partnership, and that many more we have to cover up, of course. In terms of CBNST, we had started with, and that is we had completed your unit 1, unit 2, and we are dealing with unit 3 as well. We surely been completing that soon as well. Coming towards your chemistry for class 11th part 1, where we had done your some basic concepts of chemistry, structures of atoms, classifications of element and periodicity in the properties, and unit 4 we had done unit chemical bonding and the molecular structure. Unit 5 is your states of matter, unit 6 is your thermodynamics, and unit 7 is your equilibrium. That all we had done. Even though we are dealing with your unit 8, which has been the redox reaction, where we had started with, which is we had completed your classical idea of the redox reaction, which has been oxidation and reduction reaction we are dealing with. After completing this, we will start discussing about the redox reaction in the terms of the electron transfer reaction, oxidation number, which we have started, redox reaction and electrode process we have to cover up here. After talking about completing the unit 8, we will start discussing about unit 9, which has been hydrogen, where we have to cover up the position of hydrogen in the periodic table, dihydrogen, which has been H2, preparations of dihydrogen, H2, properties of dihydrogen, hydrides, water, hydrogen peroxide, H2O2, heavy water, D2O, and dihydrogen as a fuel. Unit 10, we have to cover up the block element, which is being group 1 element, alkali metal, general characteristics of the compound of the alkali metal, anomalous properties of the lithium, some important compounds of sodium, biological importance of the sodium and potassium, group 2 elements, alkaline earth metal, general characteristics of the compound of the alkaline earth metal, anomalous behavior of beryllium, some important compounds of calcium, biological importance of the magnesium and calcium as well. Unit 11th, we have to cover up the p block element, which is being group 13 element, the boron family, important trends and anomalous properties of the boron, some important compounds of boron, uses of boron with aluminium and their compounds, of course. After that, which has been the group of 14 element, the carbon family, the important trends in the anomalous behavior of the carbon, allotropes of the carbon, some important compounds of the carbon and silicon as well. Then we have to cover up the unit 12, which has been the organic chemistry, some basic principles and technique, which we have to cover up the general introduction, tetravalence of carbon, shapes of organic compound, structural representations of organic compound, classical of organic compound, classification of organic compound. Then we have to cover up the nomenclature of organic compound, isomerism, fundamental concepts in organic reaction or mechanisms, methods of purification of the organic compound, qualitative that we have analysis of the organic compound, and quantitative analysis as well. In unit 13, we have to cover up the hydrocarbon, which has been the classification, alkanes, alkenes, alkynes, aromatic hydrocarbons, and carcinogenicity and toxicity as well. In terms of unit 14, we have to cover up the environmental chemistry. In that, we have to cover up the environmental pollution, atmosphere pollution, water pollution, soil pollution, industrial waste, strategies in a control environmental pollution, green chemistry, that we have to cover up here. So here we're gonna end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you.